Hi everyone, and welcome to the SimpleGripper project. In this video, I'll walk you through building an open source 3D printed robotic end effector. The SimpleGripper was designed to be affordable and easy to assemble. It features a parallel gripping mechanism with an articulating wrist. I started this project because I couldn't find exactly what I was looking for, and I wanted to give back to the open source community. The design was inspired by the AR4 Servo gripper designed by Chris Annan for his AR4 robotic arm. If you're interested in open source robotics and haven't heard of the AR4 arm, you should definitely go check it out. I'll post a link in the description. My goal for this project was to create a simple and affordable robotic end effector, and while it could use some refinement and possibly even a complete redesign, I think it's not a bad gripper. So without further ado, let's jump into the construction of the SimpleGripper. To build the SimpleGripper, you'll need a 3D printer. I used the Elegoo Saturn III Ultra SLA printer, but an FDM printer would probably get you stronger parts, so use whatever you have. If you are using a resin printer, I would recommend using an ABS-like resin to make sure that your gears and claws are strong enough to work with this design. You'll also need a set of 25 kg DS3225 servos, and some basic electronic components like a battery and a microcontroller. We'll also use standard tools like a screwdriver, drill, and a hacksaw for cutting the stainless rod. And finally, you'll need the various screws, bearings, and some white lithium or other grease to lubricate the gears. The full list of materials needed and links of where to buy them is in the description and also on the instructables page. I didn't film the 3D printing, but don't worry, I found some stock footage online. The SimpleGripper consists of 11 individual components that you'll print using your 3D printer. Like I said earlier, I'm using the Saturn III Ultra, which I like because it makes really smooth prints, and with ABS-like resin, the mechanical strength is probably less than a typical FDM printer, but not bad for my purposes. I'll probably end up getting a bamboo A1 at some point so I can print stronger gears from nylon, but for now, this will have to do. My printer also makes the holes a little smaller than they should be, so I'm taking some time to drill them out. If you're a responsible 3D printer owner, you probably won't need to do this step, but who knows. I did also tweak my design a little to print better on my system, so it's probably a good idea for you to be ready to make some slight adjustments as needed. Now that the parts are printed, let's begin assembling the base. The part names I chose are a little bit confusing, but I'm not going to change them at this point, so please bear with me. Start by attaching the servo motors to the motor housing using the number 6 self-tapping screws. Next, super glue the 3mm by 25mm stainless rod into the designated hole, then slide the clamp drive gear onto the rod. I also don't have footage of cutting the rod to size, so you'll just have to use your imagination for that step. Next, you'll need to secure the clamp housing bottom to the motor housing using 6 self-tapping screws. Secure everything firmly, but be careful not to over-tighten the screws. Now we can assemble the clamp. Begin by placing the left and right clamps into the clamp housing. Flip the assembly back over and insert it into the clamp drive gear. You might need to wiggle a little bit to get the gears perfectly aligned. Once aligned with the clamps fully extended, slide the clamp key through the clamps and secure it with 2 self-tapping screws. It's important that the clamps are fully extended, otherwise the code I have will break the gripper. If you're using other code, don't secure the clamp housing until you've moved your servo and made sure that you know what it initializes to, and put in a code to prevent overextension. I definitely broke a few prints figuring this out. Finally, attach the clamp housing bottom to the clamp housing and apply a thin layer of white lithium grease to the gears and sliding areas. Last but not least, we'll assemble what I'm calling the wrist mechanism. Start by inserting the bearing into the wrist mount, then attach the wrist mount to the wrist outside gear using 4 M3x16mm Machine bolts, and make sure the gear is securely attached. Finally, connect the motor housing to the wrist mount using a single M3x8mm bolt. Your SimpleGripper's wrist is now fully assembled and ready for action. With the mechanical assembly complete, let's move on to wiring and coding. I'm using a Teensy 4.1 microcontroller to control the gripper's servos. Connect the wrist servo to pin 9 and the claw servo to pin 10. In my case, the SimpleGripper is part of a larger robot arm, so I'm using a 22-volt battery with a step-down converter. But you can use other power sources like the power supply shown in this schematic. The code example I provided in the description will need to be modified to whatever controller you're using, but it's pretty simple and has placeholders for those parts. Now that everything's wired and coded, it's time to put the SimpleGripper to the test. It can only rotate about a quarter turn, so it's not amazing, but it's still helpful when trying to align the claw to pick something up. I hope that this tutorial was helpful, and this, of course, is an open source project, so I encourage you to try building your own and experiment with different configurations. You can find all the details of this project, including the 3D print files and code, on my Instructables page. And if you have any improvements or feedback, please don't hesitate to let me know in the comments. Thank you for watching, and I look forward to seeing how you use the SimpleGripper in your projects.